Hello, everyone. We're starting. So I have a question for you. How many of you are working on a monolith that you have seriously considered rewriting from scratch? OK, so some people. Well, we were in that exact same position. We have a PHP monolith that is messy and tightly coupled on the one hand, but it's also serving millions of requests and paying the bills on the other. In this talk, we will show you why, instead of rewriting our monolith, we decided to evolve it instead. I'm Penelope.
And I'm Chrysos.
And we're engineers at P.Nastou, a learning technology company building products like Talent LMS, used by tens of thousands of organizations and millions of users worldwide. And this is how we introduced event-driven architecture without breaking everything. So there comes a point in every system where synchronous processing stops being enough. For us, that point showed up in mass actions. So mass actions are simple operations applied to large numbers of users. For example, enrolling hundreds of users to hundreds of courses, deleting large sets of data, or creating groups at scale. What used to work instantly for small customers started timing out or blocking requests for larger customers. So a single request was trying to do too much, and it simply couldn't keep up. So at first, we tried to work around it, save it, keep our synchronous architecture. We broke the work into smaller chunks handled through iterative requests, as you can see on the slide. Each request processed a subset of the data, and then it triggered the next one. But this worked only for a while, and it came at a significant cost. So we made the system worse. We made the system much more complex, harder to reason about, harder to debug, harder to monitor, and much harder to trust in production. More coordination was needed between requests, and many edge cases showed up. We added polling logic on the client side without real guarantees that everything would complete successfully. And despite all that effort, we were still fundamentally tied to synchronous execution. So at that point, it became clear we couldn't keep pushing further within the request cycle. So we stepped back and asked a different kind of question. Not how do we make this faster, but does this need to happen during the request at all? So we explored one main alternative option, extracting this functionality into a separate microservice, a dedicated service to handle mass actions asynchronously. But that quickly exposed a deeper issue. All our business logic lived inside the monolith, scattered, tightly coupled, and not designed to be reused externally. To move it out, we wouldn't just be extracting code, we would effectively be rewriting that logic in a new environment, untangling years of accumulated complexity along the way. And doing that in a system already in production, serving real customers, is not just a technical challenge, it's a business risk. It also wouldn't solve the immediate problem we were facing. We didn't want to modernize just to follow the hype. We were trying to solve a very specific problem without making the system worse. So we needed something in between, something that would let us move heavy work out of the request cycle without rewriting the system, and without introducing tight coupling between new components. That's where events came in. Instead of executing everything immediately, we started thinking in terms of signals. Something happens, and instead of handling all the work synchronously, we emit an event. That event represents something that has already happened, and other parts of the system can react to it independently, asynchronously, and without blocking the user. This allowed us to keep the monolith doing what it does well, while gradually introducing asynchronous processing where it actually mattered. And importantly, we didn't try to make everything asynchronous. We introduced a boundary, deciding what must happen now and what can happen later. So, at Epignosis, part of our team's role is helping teams adopt patterns like event-driven architectures through shared practices, tooling, and hands-on support, which meant we already had some of the building blocks, but not yet applied it to this part of the system. And this is where Christos will walk you through what we actually built and how we made this work in practice.
Thank you, Penelope. So, Penelope just explained why we needed events. I'll talk about how we approached them, and the first thing that we built was not infrastructure, was not even a line of code. Before writing a single line of PHP or TypeScript, we stepped back and asked a few fundamental questions. How can different systems understand each other? How can we, as humans, stay aligned on what we are actually talking about? What is the contract between PHP and TypeScript, or different other languages? And what should the contract between different products look like? So, we started by defining the event schema, metadata, typing, and payload roles, so that every published message would be structured rather than just ad hoc JSON. On top of that, we created the event catalog, the authoritative source of truth for event types and versions. And here, we can see that it's just a sample of our payloads. And you can see that we have an event type, mass action, Penelope just already mentioned earlier, schema versions, metadata, and the payload data that we need. The interesting part is that it all started with a simple spreadsheet file. And why? Because events are not only for developers. Non-engineering teams like product teams, stakeholders, designers also need a clear high-level view. So we needed something visual, editable, and structured at the same time. It was just columns and fields, event name, version, payload fields, not something fancy. But it gave in every engineer one place to look and immediately understand what each event contained. That shared agreement, established before any infrastructure was built, is what made everything else possible. The pipeline starts with a spreadsheet, which is our single source of truth. From there, we generate the Zod schemas for TypeScript and PHP event classes for the monolith. So instead of maintaining the same contract in multiple places, we define it once and generate everything from it. That keeps both runtimes in sync and removes manual maintenance. The flow is just simple. Update the spreadsheet, generate the code, and deploy. But the real challenge was not the tooling. It was getting people to agree on the contract first. The spreadsheet gave engineering, product, data, and stakeholders a shared place to align before anything became code. That was the real win. Agree early, then make that agreement executable. Once we had an event schema and an event catalog, the next step was clear. Ingest the events and emit them. The monolith could focus on validating the request, persisting the intent, and emitting a well-defined event. Just a thin, lightweight, for the moment, request. From there, SNS propagates the event to multiple filtered SQS queues, allowing different flows to react immediately based on their role and context. As soon as you add multiple queues and execution paths, coordination becomes essential. That is why we introduced the Maestro, an orchestrator written in SJS, so we could take advantage of Node.js and the event loop for lightweight, highly concurrent coordination. Of course, its role is not to take over the heavy processing itself, since that would require rewriting business logic already living in the monolith, but to coordinate and route that work to the execution path. But route it to what? The answer is AWS ECS, Elastic Container Service. Our orchestrator listens to heavy task requests and decides which execution path to trigger. We made that choice deliberately. Instead of rewriting business logic already tested in a monolith, we Dockerized the relevant PHP components and ran them as ECS tasks. that helped us reduce synchronous pressure on the monolith while still reusing proven domain logic. We only made small refactors to run that logic through CLI commands and not redesign the business layer. So the model became simple. The orchestrator decides, ECS executes, and the monolith logic is reused through events. We wanted the architecture to be scalable, but also developer-friendly. So the monolith stopped calling downstream systems synchronously. Instead, it emits domain events through a central dispatcher. In production, those events flow through SNS and SQS into the orchestrator. But locally, the same flow can trigger PHP CLI commands. We also made the migration incremental. Legacy events can pass through adapters that map old shapes into the new model. So teams can adopt the approach step by step without a risky big bang rewriting. And because schemas are generated from the event catalog, every event is typed, versioned, and validated. That gave teams a faster feedback loop and make the new approach easier to adopt. Because what we call legacy is often the place where the business actually lives. And if your new architecture has no way to carry that forward, then it is probably not a migration strategy. It's just a rewrite fantasy. That was the principle behind everything we did. Keep the proven business logic, improve the execution model, and make the old system part of the new architecture instead of treating it as an enemy. Thank you very much for your time. Any questions? Okay, just a reminder at 12 and a half, we have a contest on our booth downstairs. So we're happy to see you there. Thank you.